All right, this is lecture 10.1, the rectangular coordinate system. Now, what we've been working with for the past or the beginning and end of the semester, working with like a lot of algebra, learning how to solve equations. We learned how to manipulate formulas, which is going to come into play for all of this stuff. And now we're learning something a little different, like graphs and how to plot data. Now, if we look at this, you might be familiar with some graphs. You might have seen graphs in the news, revolving around the virus. We talk about those. They talk about exponential increase. You might have heard logarithmic and other things. Thing is, those are actual graphs, and you'll learn more about them in college algebra. But in this class, we're going to learn like the very basics of graphs and what they are. So 10.1 just starts out with what is the rectangular coordinate system and how we do graphs. Usually whenever we have graphs, we always have some kind of input, which is going to be right there on the x-axis, which is right here. Tap in because the screen will move if I drag. But this is the x-coordinate system right here. This is your y-coordinate right here. So normally, for any kind of graph that we're reading, we usually have input, which is time in this graph, and this is our output. This particular graph, I believe, is showing about like smoking. If you smoke a cigarette at 0 minutes, right when you start smoking the cigarette, 5 minutes later, it shows an increase on the graph. You see that it increases and goes up. Your beats per minute start at 60 when you haven't smoked it, and they go all the way up to 95 beats per minute, 5 minutes after smoking. Now, as you can see, the graph goes downward afterwards. A little bump up right there, but it goes generally down from the moment you hit the 5 minute mark. So this is what graphs are good for. They're good for like seeing things. We can visually see what's happening when things go. With the whole virus thing that we're talking about, you've been seeing as time goes on, there's like this exponential increase. It'll show like a graph that curves up. It might look something like, let's say like this. There'll be like a graph, and it'll show as time goes on, the virus increases exponentially. But we would call this bottom part time, and we'd call this infected, like the number of people sick or something. And that's what's happening. This is a visual, and that's what graphs are doing. They show us like a visual representation of what's going on, and we can just easily see things. We look at it with profit margins. We look at it in this case, sickness. This case, for this example right here, we're talking about how your heart rate changes over time. We can see that it increases, but then decreases gradually, and will most likely go back to whatever your resting heartbeat was afterwards. So that's what graphs are. And normally we have like a positive input and a positive output, because in real life situations, we don't really have, you know, negative time. We call negative time the past, right? Or we can just write it as positive time. Then our output, like if we talk about beats per minute, we don't have a negative heartbeat or anything, so our heart can't go negative beats per minute. So we keep a positive time and a positive beats per minute. But generally speaking, all graphs have this coordinate system. The XY axis, it represents a positive portion and this is a positive, and this is a positive, but it also has other quadrants involved for this. As you can see in quadrant 1, we have positive 1, 2, 3, 4, 5, and positive 1, 2, 3, 4, 5 for the y-axis. Going counterclockwise, we count the quadrants. So it goes quadrant 1, quadrant 2, quadrant 3, quadrant 4. So the quadrants, going to zoom out because I need this little tool here. The quadrants go in this direction when we read them. So if we write them down, you start out with quadrant 1, then it goes to quadrant 2, quadrant 3, and then it goes to quadrant 4. And they go in a counterclockwise. motion. Now, don't necessarily need to know the quadrants. There are going to be a couple questions on the exam and on the homework that ask where it's located. It's not necessarily difficult, but it's kind of easy to mix them up. Some people might accidentally write, oh, let's draw another graph. They might write down quadrant 1, 2, 3, and 4 because they're going clockwise, they're going this direction. But we know that would then be wrong. It always starts off and goes this direction. 1, 2, 3, then 4. And that's what we want to do. So we're going to use the quadrants to locate where each graph is, or each point in the graph. So some important things to know is that you see the numbers on the right side of the x-axis are positive. All the numbers on the left side of this y-axis are negative. All numbers above the x-axis are positive, and all the numbers below the x-axis are negative. The easiest way to think about this is whenever we count to the right on a number line, it always goes positive. Whenever we count left on a number line, it's negative. So this x-axis looks just like a number line that we've been working with. If we count up, that represents positive numbers on the y-axis. So think like above you, and whenever we talk like below, we always say negative. So we say downward is negative, upward is positive. So that's kind of like how to read the coordinate system. I'm using the e-textbook just for a couple of examples, and then I'll show you all through this app, and we're going to write some problems just like I do up on the board in class. Now, looking at this, we represent coordinate points by having the input, which is going to be our x-axis right here, and then our y-axis is our output. So here, if you look right on this point right there, it says 3, 2. What that means is our input is 3, our output is 2. So what we do in order to graph any kind of point is we'll count for the first number 3 units to the right, and then 2 units up. So you go 1, 2, 3 to the right, 1, 2 up, and that gives you 3, 2. Notice the other point off to the left side. We have -2, 5. So this one, you always start from the center, which is called the origin, as you saw on the diagram earlier. Go to the left 2, and then the +5 means go up 5 units. So your first number always represents your horizontal movement. So the 3 and the -2 represent horizontal movement. The 2 right here and the 5 right there represent vertical movement. So it's going to be 3 units to the right, 2 units up. 2 units to the left, 5 units up. And that's all there is to plotting a point. So if you look at this example down here. Scroll up a little bit. We can see it might be a little confusing. You see one says 3, 2, the other one says 2, 3. And this is where you have to really pay attention to detail. The input for the blue dot is 3, the output is 2. The purple dot, or magenta, whatever you want to call it, is 2 for the input, 3 for the output. But you can see that they're located in different spots. And this is a common mistake. People might flip-flop them on accident. We know 3, then 2 means count 3 to the right, then up 2. 2, 3 means 2 to the right, up 3. And that's the main difference between them. But you see, just switching the numbers around gives you different points. And surprise, surprise, this is where math has details, right? You got to pay attention to all the details when graphing. But actually putting the point down isn't necessarily difficult. You'll be doing graphing from here in chapter 10 all the way to 10.5. The next class a little bit, but college algebra, yeah, you're going to be graphing all the time. You're going to graph things like parabolas, the exponential equations I showed you earlier, everything. So there's going to be a bunch of different stuff that you're going to see. So plotting graphs, it'll come to you because you use it very often, just like we did with solving equations. So let's go ahead and graph these points. I'm going to go ahead and write these on my other app. I have another screen up that shows me the points. So let's go over here. So this is example 1 from the book. It wants us to plot A, which is 5, 3, B, which is -5, 3, C, -2, -4, D, 1, -2. Let's start with these really quick. Now, we can graph all of these up on the same coordinate plane, which is fine. You can graph them on separate ones, but we're just going to graph them all on the same one. And a lot of points. Whew. All right. Now look at this. Everybody's favorite. Got a fraction right here. -5 1/2. And then the last one, I. And that's 4 2/3 and -3. Okay, so I'm just going to use some little tools I got here to make myself a little graph. Whenever you're sketching a graph, it doesn't have to be perfect, like in terms of straight lines. I've got a computer here, so kind of cheating. Even this line might not be completely straight. There we go. Look at that. I couldn't do that, but on the whiteboard, huh? Look a little sloppy. All right, all graphs, you kind of want to put these little arrows on the end to show that the graph keeps going. And when you draw or sketch your graph, you can put these little marks. These are like tick marks. And you can number them however many you want. I like to keep them proportional. I'm going to do 6. So it'd be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But I like to keep it proportional, meaning like 6. If I'm going to do 6 on the right side, 6 on the left side, I'll do 6 on the top and the bottom as well. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, your graph doesn't have to be perfect, but look at this, for instance. Like whenever we're talking about like this distance between all of these little tick marks, you kind of want them to be the same distance. You want it to be kind of proportional, because if they're not proportional, then your graph's not going to look correct when you end up graphing it. You want it to be as proportional as possible. Same thing with these right here. I tried to make this about the same distance as this one, and as this one, and as this one. Want to try your best to make them as proportional as possible. So let's go ahead and graph them. I'm going to graph, I like blue. Blue's a good color. Let's go ahead and graph 5, 3. So do 5, 3. That'd be 1, 2, 3, 4, 5. You're going to count 5 to the right, and you're going to go up 3. 1, 2, 3. And I'm going to put a big old dot there. There you go. And then you want to label it A. That would be point A. So you want to label your points just like that. That's important. So let's go ahead and I'll do like green for this one. -5, 3. 1, 2, 3, 4, 5 to the left, and then up 3. 1, 2, 3. Draw a little dot there, label it B. All right, I'll do purple. I'm just going to kind of mix up these colors. C, -2, -4. So the -2 means left 2, 1, 2. So I'm like currently right here. And then down 4, 1, 2, 3, 4. And there's letter C. Not too bad, right? I just kind of get the hang of it. It's kind of hard to like, can't really point on this thing. I can't get any of y'all's feedback, but that's all right. That's what the Zoom sessions are going to be for. Now D, let's do that one. 1 to the right, down 2. So 1 to the right, down 2. Should be right there. Let's do orange. E, 0, 0. So what that means is this means 0 to the left, 0 to the right. So if you were to guess where it would be right in the center, right at the origin. All right, F. That one's a little tricky. So F is going to be 0. The 0 right here means no left or right movement, but the 2 right there means we're going to move up 2 units. So 0 movement to the left, up 2 units. Going to start in the center, go up 2. That would be where F is going to be. All right, I'm going to do blue again. Here we got the other one. We got the 0 right here on the second number. So 0 on the second number means no Y movement. So there's not going to be any Y movement. I forgot to put this X and Y coordinate graph. So this would be -5 to the left, 1, 2, 3, 4, 5, and then 0 up and down. That would be G. All right, let's go ahead. Let me use magenta color. This one, a little tricky here. Remember the 0 here is the first number, so that means 0 left or right movement. So we're going to go 0 left or right. And then this right here, the -5 and 1/2 means we're going to go down -5 and 1/2. So we're going to go 1, 2, 3, 4, 5. Now remember the half means we don't quite go to -6. We go halfway to -6. So that'd be like right here. That would be H. Okay, which color haven't I used a lot? Green. All right, 4 2/3. So that means 4 2/3 to the right. We have to count a whole 4. 1, 2, 3, 4, and we have to go up 2/3. So 2/3 means it's not it's not all the way to 5, but it's kind of close to 5. So 1, 2, 3, 4, and 2/3, right about there for the X mark. So we count about right there. Now we're going to go down 3 for this number. So we have to go 1, 2, 3. That would be I. So you can see how it lands about right here. That's about 2/3, 4 2/3. And right here is the -3 mark. That's all the points marked on there. Now, if we were to label where they all occur, remember the quadrants are 1, 2, 3, and 4. And this is the x-axis and the y-axis that are listed here. So if we were to say where they're landing, A lands in quadrant 1, B lands in quadrant 2, C lands in quadrant 3, D lands in quadrant 4. E, we'll say, lands at the origin. F lands on the y-axis. G lands on the x-axis. H lands on the y-axis. And I lands in quadrant 4. So that's where we label each and every one of them and where they occur. So that's graphing as far as all those points. So graphing is going to be the main thing for this course. You're going to have to be doing it all the time. All right, let's move to this next page. Let's see what's over here. Now, graphing paired data. So you can see on the example, that's what they did. They got all this right here. Now, let's look at this over here. Graphing paired data. Right here, this is something where we have like inputs and we have outputs. It's a table. So it tells us the year for the company. Here it's Target. It's my college work, alma mater. And it shows how much they made in billions of dollars each year. So in 2013, they made $71 billion. 2014, they made $73 billion. 2015, 74, 16, 70, and 2017, 72 billion. Now, what it wants us to do is we're going to write these as ordered pairs. If I want to write those as ordered pairs, We can write them as 2013, 71, 2014, 73, so on and so forth. And we're going to create something called a scatter diagram, which means we're just going to put the points on a graph. And then we can test to see what the trend is. We want to see what the trend is for the points. But if you look at this, goes 71, 73, 74, 70, 72. You can see that like an increase numerically, then a decrease, then an increase. But whenever we graph data points, it's easier to graph them so we can actually see it visually. So if we go to the next page, we can see the graph that the book gives us. Here we have the scatter plot. So we can look right here. They have a scatter plot. Oh my goodness, the book. Here we go. And you can see the input shows 2013, 14, 15, 16, and 17. Output is how much they made. And you can see it increases, big drop, decrease, and then an increase. And, whenever we look at these graphs, we're like, oh, increase, population increases. We usually think sales should increase, or maybe there's some sale campaign that went on. We don't know. But the company can analyze things like this and look to see what caused that increase. But more importantly, they see this. 2015 to 2016, there was a big old decrease. Like, oh, God, what do we do there, Need to hire Mr. Morgan again to come and work for us, get our sales up. I was just a measly stockroom employee, just doing my duty in the back. But anyway, this drop, they can look and see what happened. It could be, I don't know, it could be a recession. There was not necessarily any recession at that time. There could have been not as much stock. There could have been a bunch of things going on with this graph. So a lot of things could have been affected by that. But then they see an increase, so they probably like that. So we can see that the profits and everything increased again. Now, if you look right here, there's this little zigzag line. That little zigzag is a break in the graph. Basically, the graph still starts at 0, right at the very corner of the graph, right there. But then it jumps to 68. This little break in between just represents all the numbers between 0 and 68. And there's no need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, $10 billion because they did not make anything below $68 billion for these data sets. So there's no need to put any numbers in between those. So that's how they graph it. Scatter plots are useful. So let's look at this next one. I'm going to kind of jump over to example 3, and we're going to see how solutions or how data points are solutions to equations. Now, way back over in chapter 3, we did things like, let's go on the next page. Remember, we did things like we had x plus 2 equals 4, and we said check if x equals 3 is a solution. We did things like that, and we were like, oh, 3 plus 2 equals 4, 5 equals 4, uh-oh, it's not a solution. But when we're talking about linear equations are always made up of 2 variables. We've only been working with 1 variable throughout all of this stuff. Now we're going to be working with 2 variables. So if we look here, we have example 3. It wants us to determine if each ordered pair is a solution to this equation. X minus 2y equals 6. So that's our equation. It's still an equation because it has an equal sign. It has 2 variables, x and y. Now, what it wants us to do is check to see if 6, 0 is a solution, is 0, 3 a solution, and is 1, negative 5 over 2 a solution. We're going to be checking to see if these are solutions for the equation. To do that, on this problem, oops, keep clicking everywhere. This problem right here, we plugged in x equals 3 for that. Here, remember, all of our coordinates are made up of x, y coordinates. This is our input, this is our output. So this is our x and our y, our x and our y, our x and our y. So we want to check each individual problem and plug them in. We're going to plug them into this equation, the main one. So x minus 2y equals 6. Plug in 6 and 0. Instead of x, we're going to put 6, and instead of y, we're going to put 0. And we're checking to see if both sides equal. PEMDAS says 6 minus 2 times 0 is 0. 6 minus 0 is 6 equals 6. Since that does equal both sides, that is a solution. And we have to do the same thing for b. X minus 2y equals 6. X is 0. 0 minus 2. Y is going to be 3. Plug everything in. PEMDAS says to do multiplication first, so we have to do this first. So negative 2 times 3 makes negative 6. 0 minus 6 then makes negative 6. Negative 6 does not equal 6, so that means not a solution. Okay, and then fractions, everybody's favorite. Plug in 1 for x, and then negative 5 over 2 for the y. Now, notice how I wrote the fractions, like I wrote the numerator with the numerator and the denominators down here. The way I wrote them, I made sure the two numbers are up here and this is on the bottom because it helps us see the difference between the numerator and the denominator. You know, write it nice and neat. Because the cool thing about this is the 2 and the 2 cancel out, right? 2 divided by 2 makes 1. We went over that with fractions. So we can just rewrite 1 minus negative 5 equals 6. We look at this, a negative times a negative is going to make a positive. 1 plus 5 equals 6. 6 equals 6. That would be a solution. And that's all we want to do is if it says check to see if an ordered pair is a solution, that's all you got to do is plug in each and every one of them. Now, moving on to example 4. Remember, we're used to solving equations, right? We don't usually test to see if something is a solution or not. We usually use that to check our answer all the time on tests. So whenever we don't really use this check to see if it's a solution. We usually use this check thing whenever we have a solution. We just want to make sure it is a solution. But oftentimes, like example 4, it gives us this equation, 3x plus y equals 12. And it wants us to find the missing value for all the points. So it writes it like this. For letter A, it leaves the y area blank. For B, it leaves the x area blank. And for C, it leaves the y area blank. So we have to find the missing value. Remember, this is x, this is y, x, y, x, and y. So what we have to do for each one is solve for the unknown variable. 3x plus y equals 12. We're going to take 0 and plug it in for the x. 3 times 0. The y just stays the same because we don't have anything for the y. We're trying to find what the y value is. So we're going to put plus y equals 12. Then you use all your algebra techniques that we learned in chapter 9 to find the solution. So 3 times 0 is 0. And then your next step, well, you don't really subtract 0 on both sides. 0 plus y makes y. Y is equal to 12. That's your solution for that. So our coordinate point within B, 0, 12. We want to find out what it is. Erase all these hand marks. Okay, then B. Divide this. 3x plus y equals 12. Here we have x missing. So we have 3x plus substitute 6 in for that. Start solving for x. First step, and remember if you kind of have the process down and everything, you're kind of used to solving the equations by now, so you pause the video and try working it out yourself if you like and see if you get the same answer I'm about to get. For this one, you'll have to subtract 6 on both sides. 3x equals 12 minus 6 is, that's right, guys, that's right, 6. Can't hear y'all. And then divide by 3 on both sides. X equals 2. So x equals 2 is your answer. So that would mean your coordinate point is 2, 6. Okay. I'm going to take C and we're going to do letter C down over here. All right. Now C, we have 3x plus y equals 12. Here they gave us x, so substitute x and start using your PEMDAS algebra. 3 times -1, -3, plus y equals 12. We're going to have to add 3 on both sides. And that gives us y equals 15. So your coordinate point would then be -1, 15. And that's all you got to do. So to solve each individual one, you got to see which one is the unknown variable, solve for the unknown variable. Again, the process isn't difficult if you got chapter 9 down. Everything's going to be solving equations usually for math. I mean, that's the whole point. Like, how can we solve this problem? Solving ordered pair problems is no different. Now, your homework might do it like this instead. Let's pop up the book. I'm going to kind of go over to the next page. It's not that page, it's the next one afterwards. Okay, here we go. So you can see like it'll give us complete the table with the y and the x's missing as a table. That's fine. What we just did on the last problem was something like, oh my goodness, there we go. Wasn't going back. I'm on my touchscreen tablet. Here it had it as blanks for the y and the x, but this one has it as a table. And it's so different. My math lab's going to do problems like that. So let's do example 5. Do example 5 right here. Wants us to solve for missing variable. Now, I'm not going to draw a fancy rectangular chart. What we'll usually draw is something called a T-chart. It's the same thing, just minimalistic. It's called a T-chart because this looks like a T. And we still have our x and our y. It gives us -1 for x for that one. For another point, it gives us 0 there, and it gives us -9 here. So as you can see, we're missing y for this part, we're missing x here, and we're missing x here. And we have to solve for the missing variable with the equation y equals 3x. Now, this is called letter A, letter B, letter C. So let's look at A. A, we have -1 blank. So y equals 3x. They give us x, so we have to substitute -1 for x. That gives us y equals -3. Take this answer right here, and you're going to write it right here, -3. That's all there is to it. Do B. For B, I'm going to write down y equals 3x. And we're going to substitute this time. Wants to substitute 0 for y. So we have to put, oops. That's my hand touching that. We have to say 0 equals 3x. So to solve for x, you would have to divide by 3 on both sides. 3's cancel out. 0 divided by 3 is 0. 0 is equal to x, or rather, x is equal to 0. So for that one, for that answer right here, we get 0. So 0, comma 0 is that coordinate point.